Today, we're going to get right to the heart of reality itself. We're asking one of the biggest questions you can ask. What is everything actually made of? The answer, it turns out, is both way simpler and a lot more incredible than you might think. Seriously, just take a second. Look around you right now. The phone or computer you're watching this on, the chair you're sitting in, even you. What is all this stuff really? Well, scientists have a word for all of it. Matter. From a staircase to the air to the water in your bottle. But here's the kicker. Almost nothing you interact with is just one single thing. Reality, it turns out, is mostly a big jumble. That's right. See, most of the world is a combination of different things all just kind of hanging out in the same space. And in science, we call these combinations mixtures. Think about something like a sprout salad. You've got your chickpeas, your onions, your tomatoes. They're all tossed together, right? But the chickpea is still a chickpea. The tomato is still a tomato. They're in the same bowl, but they haven't fundamentally changed. Same thing with lemonade. It's just sugar and lemon juice stirred into water. All the original ingredients are still in there. And this actually shows us that there are two main kinds of mixtures. First, you've got your non-uniform ones, like the salad, where you can literally see the different parts. But then you have uniform mixtures, where everything is so perfectly blended together that you can't tell the components apart at all. Kind of like when you dissolve sugar and water. And you know what? These uniform mixtures are absolutely everywhere. The air you're breathing right now? That's a uniform mixture of nitrogen, oxygen, and a bunch of other gases. That stainless steel sink in your kitchen? That's an alloy, a uniform mixture of iron, chromium, and nickel. They are totally hidden in plain sight. Okay, so if most things are mixtures, what does it mean for something to be pure? Well, this is where our everyday language can get a little tricky, because for a scientist, pure means something really, really specific. This is such a key idea. You might buy a carton of pure milk, but to a scientist, that milk is actually a mixture of water, fats, proteins, and a lot more. So when a scientist uses the word pure, they mean something completely different. And this is it. A pure substance is made of only one single type of particle. You can't separate it into other things using physical methods, like filtering it or picking bits out. This is our foundation. But get this, even pure substances come in two different types. All right, now we're getting to the very heart of it all. All pure substances can be divided into two basic categories, elements and compounds. And to really get the difference, let's check out a classic experiment. So, imagine this. We take some pure water and we pass a little electric current through it, say from a 9-volt battery. Right away, you'd see bubbles streaming off the metal contacts. But as we collect these gases, something really strange happens. One of our test tubes is filling up exactly twice as fast as the other one. This whole process is called electrolysis, and it's literally splitting the water apart into two brand new substances. And it always happens in this exact 2-to-1 ratio. The gas we have more of, that's hydrogen, and the other one is oxygen. So think about what just happened. We started with one pure substance, water, and we broke it down into two new pure substances, hydrogen and oxygen. And this very process shows us the critical difference between an element and a compound. So that hydrogen and oxygen we collected, those are elements. You can't break them down any further. They're as simple as it gets. They are the fundamental building blocks of, well, everything. They're like the universe's Lego bricks. And the water we started with? That's a compound. It's what happens when elements chemically lock together in a specific, fixed ratio. And this isn't just a simple mix. Oh no. It is a complete transformation. The new thing you create has totally new properties. This is the part that just blows my mind. You take hydrogen, which is flammable, and you take oxygen, which fire needs to burn, and you combine them chemically. And what do you get? Water, a substance that puts fires out. The compound is absolutely nothing like the elements that make it up. Let me give you one more quick example. If you just mix iron filings and sulfur powder, you have a mixture. The iron is still iron, you can pull it right out with a magnet. But if you heat that mixture up, a chemical reaction happens, and you create a new compound, iron sulfide. And all of a sudden, the magnet does nothing. A completely new substance has been born.
So, mixtures, compounds, elements. Why is it so important to get these ideas straight? Because understanding how to take things apart and how to put them back together in brand new ways, that is literally how we've built our entire modern world.
Understanding how elements combine into compounds is what lets chemists design life-saving drugs. It lets engineers create super strong alloys like stainless steel. It even leads to incredible wonder materials like graphene aerogel, one of the lightest solids on the planet. From ancient art to the latest technology, this knowledge is what makes it all possible.
And what are we building all of this with? Well, as of today, we know of just 118 elements. That's it. Everything we've talked about, everything in the entire universe that we know of, is built from this one finite set of ingredients. So, I'll leave you with this final thought to chew on. What if water wasn't a compound? What if it was just a simple mixture of flammable hydrogen gas and the oxygen gas that fires need to burn? Just think about that for a second. Our world would be a very, very different place.